Well, let's go ahead and get started. So today's talk in the graduate admissions workshop, we're way over here in the circle under funding, I think, is on external fellowships. And let me just tell you a little bit about myself because I haven't introduced myself yet. And so my name is Professor Gary Kunkel. I'm not going to tell you much about my research, but so I have been at Texas A&M for a long time, since 1989, in the Department of Biochemistry and Biophysics. I received a bachelor's degree in chemistry from the University of California, Davis, and a PhD in biochemistry from UCLA. As you can tell, I grew up out in the California area. And then I did a postdoc way out in Massachusetts, near Worcester, Massachusetts. Just a couple of words about my research. And the reason I'm not going to tell you very much is that I'm actually retiring soon. So I have worked for many years on eukaryotic transcriptional control. And my lab has studied the transcription of small RNA genes. And in the last 10 plus years, we've used the zebrafish model system to study transcriptional activation. Now, why am I talking to you today? It's because I've served on graduate fellowship panels at the NSF, National Science Foundation, from 2012 to 2017. And specifically, the fellowship that I'm going to focus on today is one sponsored by the National Science Foundation, that I'll say NSF, and it's the Graduate Research Fellowship Program. This is probably the largest national graduate research fellowship program that exists in the United States. A couple words about the NSF, because some of you may not know much about it. It is an independent agency of the federal government. It was created about 70 years ago now, and about 20% of all federal funding for research is funded by the NSF. Let me say at the beginning, I have co-opted a number of slides from the National Science Foundation. I'm going to show you the webpage, the URL, one of the last slides that describes their fellowship program. But I want to point out that the GRFP, that stands for Graduate Research Fellowship Program, it was the NSF's first national program. It's one of their flagship programs, and it supported graduate students from 1952. So it's a really long-standing fellowship program. So let me tell you about this GRFP, Graduate Research Fellowship Program. It's a 5-year award, but really it's 3 years of support. It's a really good stipend. It's a larger stipend than at most graduate institutions. And the support also contains it's $34,000 a year for 3 years, and it also contains an allowance given to the university that covers tuition and fees. So it's a really good financial deal, but really more importantly, it looks fantastic on your resume or your CV. So what are some unusual features of the Graduate Research Fellowship from the NSF? This fellowship is awarded to you, the individual. It is not awarded to your lab and a combination of yourself and your PI, as many of the fellowships that you can obtain later on in your graduate career, but it's awarded to you. So it's flexible, and it's unrestricted, and it's portable. So as I'm going to tell you in a few minutes, you can apply before you go to graduate school, and then you can use this fellowship wherever you'd like to go. Now, one of the restrictions, and I'll tell you about several restrictions as we go through these slides, one of the restrictions is that the research that's described and the research that's supported must be in a master's or doctoral program, a PhD or a master's program. It can't be used to support an MD or an MD PhD. Oh, and I forgot to say, sorry, when I started this, is that please, if you have any questions along the way, use the chat function and send a chat to Justine, and then we'll have a question and answer period at the end. I have quite a few slides, but I'm going to keep an eye on my phone here and make sure that I get done in some time for some questions. Last thing I want to say on this slide is that the GRFP is very competitive. It's about a 16% success rate. So that's pretty competitive, but that's not like out of this world competitive. It's not like a 5% success rate or something. So it's a 16% success rate. I think there's a couple thousand fellowships awarded each year in all the different science programs. And these are quite broad. Any of the fields which are supported by the National Science Foundation are included in this fellowship program. And probably the two that are most relevant to our audience here, because you're most likely interested in biochemistry or genetics, is in the chemistry or the life sciences. But just want to point out that any field that is supported, research that's supported by the NSF, is included in the GRFP program. Now, what about the eligibility? An important aspect of the GRFP is that this fellowship is only eligible to US citizens or permanent residents. So if you're an international student, unfortunately, you cannot apply for this fellowship. It is meant, as we'll see in the next few slides, for application either as a senior or very early in your graduate career. You must be a full-time student. You must be aiming to become a full-time student in the fall after you apply, or you must already be in graduate school. You cannot use this fellowship at a foreign institution. So it's highly portable, but only within institutions in the United States. Now, overall, there are 4 levels, really mainly 3 levels of experience that are supported by the GRFP. And these are called 1, 2, 3, and 4. So level 1, and what these refer to are the times at which you can apply for GRFP fellowship, although there's going to be some restrictions I'm going to come back to in just a minute about that. So the first time that you can apply is when you're an undergraduate. And your aim is to graduate during the year that you apply, and you would be attending graduate school the next fall. So that's called level 1. Then there's level 2 and level 3. These are when an applicant is already in graduate school. They're either in their first year, their first semester of graduate school, they're called level 2, or they are in the second year of graduate school, and that's called level 3. Now, level 4 is a somewhat special case. Level 4 is for students who have been out of school for a while. They may have already received a master's degree, but they've been out of school for at least 2 years, and they are not currently enrolled. So there aren't too many level 4 applications, but that possibility does exist. Now, here's the rub. It turns out that you could only apply to the GRFP twice in your career. The first time is when you're a senior undergraduate. You can apply once, your first time at that point. So you're a level 1 applicant at that point. After you get into graduate school, you can only apply once, either once as a level 2, as a first-year grad student, or once as a level 3 as a second grad student. So what kind of strategy? It becomes a little bit strategic. How do you do this? When do you do this? Well, first of all, I think I would definitely recommend that if you are still an undergraduate student, that you should definitely apply for level 1 as a senior level. That gives you practice in doing this application, and if you get it, it's a huge reward because now you have this big feather in your cap. Now, but what about if you are applying as a graduate student? Should you apply your first year or your second year? And there's really not a straightforward answer to that. My recommendation there is that if you're applying as a first-year student, then you want to make sure you have a pretty strong research proposal at that point. And I'll come back to this in a minute. If you have uncertainties about how strong your research proposal is, you should probably wait until you're level 3 for your one opportunity to apply as a graduate student. So the timeline, I haven't said anything about the dates yet, a general timeline. And this timeline is really designed for students who are still undergrads, but of course you can apply in graduate school. So the application, and I'll show you the exact dates on the next slide, it's in late October. The applications are due online. The letters of recommendation, I'll talk about in a minute, those are due very shortly after that. I think last year they were due November 1st. The actual deadlines vary by a day or two between the years. Then if you're an undergrad still, then you'll apply to graduate school. After that, you'd be applying in probably the end of November into December. Then the NSF decides on all these applications sometime usually around the first of the year. And then the offers are made by the National Science Foundation in March to April, and you have till May 1st to accept it. And then your fellowship would begin September 1st, about the time that you start graduate school. So of course, if you're in graduate school already, you of course leave out this apply to graduate school step, but it's pretty much still the same timeline. So what about the exact dates? The exact dates for 2020 for this upcoming fall are shown here. And it's, I'm going to just highlight two of these, life sciences, chemistry. Notice that these are spread out by a day or two, but they're in mid to late October for these application deadlines. And these are very firm deadlines that everything has to be submitted to the National Science Foundation website. So that means you need to get started real soon, no matter what level you are, in order to apply to this program. You don't want to wait till the last minute. So what does an application entail? What are the parts of the application? And I'm going to slow down a little bit now to go through some more details on these slides. So the first part of the application are basically filling out a bunch of boxes on the application website. Personal information, where you've gone to school, if you have any honors, or if you have any publications. These are kind of fill in the blanks, fill in the box kind of thing. But what do you really need to spend a lot of time preparing? The next two things I'm going to tell you about. There are two statements that you have to write, and these have very stringent page limitations. The first is your personal statement, limited to 3 pages. And there are, of course, as most applications, there are limitations on margins and spacing and things like that, which you can get off of the NSF website. But in your personal statement, you're going to tell about your background. You're going to say why you're interested to be a scientist. You should probably say what you're planning to do after you finish your master's or your doctoral degree. You should definitely spend a lot of time in your personal statement describing your previous research. And I'm going to say more about other things to put in there in just a few minutes. The second large statement, it's actually very limited in size, but the second major statement that you have to submit in your application is a research statement. This is limited to 2 pages. So the research statement is a proposal to describe a research plan. Now you might say, well, if you're an undergraduate senior or a first-year graduate student in October and you've just barely started your graduate program, how are you going to describe the research you're going to do in graduate school? Well, in the field of biochemistry and chemistry, it's recognized that your research, your actual graduate research program, you don't even know what that is in the fall of your first year, and certainly not when you're an undergraduate student. So your research statement, the plan that you're talking about, is going to be somewhat hypothetical. You're not likely to ever do that research. What would it be about? Well, my suggestion is that your research plan should be an extension of some undergraduate research that you've done before. Or maybe you've been finished with your bachelor's degree for a while, you've been working as a technician or a research assistant in a laboratory. You can describe an extension to the research that you've been doing before. You definitely want to know a lot about that area of research. And you need to come up with a plan, which is something that's doable in 3 years by one person, yourself, not an entire lab research plan, that would extend that. So what the reviewers are really looking for in the research plan for a level 1 or a level 2 student is their ability to think about and describe and formulate a research plan. That research plan should have specific aims, at least 2 specific aims, to describe what you're planning to do, and it should then go on very briefly, because you only have 2 pages to describe that. Now, here's a big difference between the level 2 and the level 3 applicants. Remember, level 2 is your first year of graduate school. The level 3 is your second year in graduate school. The panel of scientists that review these applications have a much higher expectation for your research plan if you are a level 3 applicant, i.e. if you're in second year in graduate school, because it's recognized you're likely to be working on your graduate research at that point. You've probably spent a fair amount of time on your graduate research. And so the expectations for the quality of that research proposal is a lot higher for level 3 applicants. The reviewers at NSF, well, they're actually scientists like myself who review these applications for NSF. We will review level 1, then level 2, then level 3, and we'll throw in some level 4s if they exist separately, so that we're reviewing like levels, similar levels of expertise among the applicants at the same time. That being said, they're all thrown into the same pool in our scoring mechanism and then evaluated. But we are reminded by the National Science Foundation that we keep in mind the level of expertise, either undergraduate, first-year student, or second-year student of each applicant. Okay, now I'm going to say a little bit more about the research statement in just a few minutes. The fourth thing in the application are transcripts. These are mandatory. And so these are uploaded. It's not necessarily, I'm pretty sure it's not necessary that they are official transcripts. They're uploaded on the NSF website. Lastly, there are letters of reference that are required. Only 2 are mandatory, but I highly recommend that you get 3 of these. And I know that Dr. Cruz-Reyes a couple of weeks ago in this workshop talked about letters of recommendation. So all of the advice that he's giving you about letters of recommendation for submission to your graduate application, the same kind of guidelines for the letters of reference to the GRFP or any fellowship application. You would certainly want to have professors who have directed your undergraduate research, supply letters of recommendation, and then other professors or scientists who know you quite well. Now at the bottom, this GRFP solicitation, there'll be a new one, I'm pretty sure, for the upcoming fall competition, but that hasn't been released yet, so don't pay any attention to this exact number. Okay, now what do you have to avoid as a research plan in a National Science Foundation fellowship? The following: ineligible fields of study. The National Science Foundation funds basic research. They do not fund health-related research. It cannot be directly health-related. It can be an area of basic research that's tied in to a disease, but it cannot be direct. The research itself cannot be directly health-related. It cannot be clinical research. It can't be research on plant pathology or on food safety. The National Institutes of Health, the NIH, is tasked with directing research in this country that's health-related and clinical-related. So this could get a little hard to figure out sometimes. And if you have any questions about whether your research plan is too health-related, then you should get in touch with NSF personnel. And I'm going to give you a website near the end here. Okay, now how are these applications reviewed? The standard review criteria for any application which is submitted to the NSF, whether it's a fellowship application whether it's a research grant application, any kind of application. These are the two basic criteria that NSF uses to review all of their applications: intellectual merit and broader impacts. These are described here in very large terms, but I'm going to go to the next slide and tell you what does this mean specifically for an NSF GRFP application. What do we mean by intellectual merit and broader impacts? What are we looking for? First, intellectual merit. So the intellectual merit for a GRFP application is going to be the following from your application: your grades, your courses you've taken, if you have any awards, if you've published any papers. Your research plan is going to be a major impact on the intellectual merit. So your plan of research, how well is that written? How concise is it? Does it seem like a really good idea? The intellectual merit, evidence of that can be found throughout all parts of the application. The personal statement, where you've described why you want to be a scientist, what research you've done in the past, your research plan, obviously, the letters of recommendation, any awards, the transcripts. The intellectual merit is based on that. That's about half of how a GRFP application is evaluated. But the second half is very important, and I think it distinguishes a lot of other fellowship applications from the NSF application, and this is the broader impacts. And this is a place where a number of applicants might not realize how important it is. It's very important. As I said, it's probably going to be the intellectual merit was one half. This is the other half of how your application is evaluated. And so what does this mean for a GRFP application? It's mainly summarized on the top line: potential impact by you on society. What might that mean? In general, it's usually, for most applicants, it's science outreach. How have you in the past, number one, and number two, how do you propose to extend this during the time after you receive a fellowship? How are you helping underrepresented groups participate in science? How are you, what mentoring have you done or do you plan to do in science, technology, and math in the schools? Increase public literacy. Maybe you've done a blog, you've done a radio show, you've participated in science clubs. You yourself, are you a member of an underrepresented minority? That's important. But even more important is, how are you planning to spread the word about science to a lot of groups that are not getting the word very well? So the broader impacts can be seen also throughout your entire application. In your personal statement, I would recommend that in your personal statement, you talk about broader impacts, i.e. science outreach mainly, that you've done previously. But it's really important that you tell about what science outreach, mainly, you plan to do if you receive a fellowship. You can include that either in your personal statement, or a lot of times it works out best to put it in your research plan. A really compelling applicant is one, to me, who interweaves their research that they propose to do and their outreach activities. This can also be evident in the letters of recommendation and in the kinds of awards you might have received. So the broader impacts can be evident throughout your application, but it must be included. It becomes about half of the evaluation process. You will receive individual evaluations from your research proposal, from your application, on both of these areas, both the intellectual merit and the broader impacts. The evaluators will actually give a score. Now, you'll never see this score, this number score, but it is used to rank all the applicants. Let me tell you that 1/2 of the fellowships are granted according to this ranking scale. just directly from the top to the bottom, from all of the applications that are received in a certain area of science. They're ranked from the top to the bottom by the evaluators, and 1/2 of all the fellowships are granted according to that. The other half of the fellowships must be in the top 1/3 of all the rankings, but the NSF will decide among that second group, they'll decide who gets a fellowship and who doesn't. Because the NSF wants to distribute fellowships so that they don't all go to students that might be at Ivy League schools and all the top schools. They want to make sure they're distributed among all the different states and everything. And so there's some flexibility there. Okay, I promised I would show you something about some resources at NSF. These 2 websites, you can get information about a lot more information about the fellowship. I've taken almost all my slides from some PDF files that I found on one of these websites. I don't remember which one, but you can find a much greater number. And these numbers, they will update these solicitations, I'm pretty sure, very soon. They'll probably see NSF 20 something. It will give detailed information about the application itself. And those will be found also on these websites. Just a couple more minutes before we go to questions. I want to mention 3 other national fellowships that are available. The first one's a private foundation, the Hertz Foundation. It's very selective. This provides 5 years of support, also tuition, some dependent child support if it's needed. Here's the website. Go to this website if you're interested. The application process is also in the fall. You can apply as either a senior undergraduate or a first-year grad student. Very selective. Only 16 fellowships were awarded in this last year from applications that were submitted in 2019. There's another national fellowship I'll mention quickly, the National Defense Science, I just thought the science here, NDSEG, National Defense Science and Engineering Graduate Fellowship. Here's the web URL, 3 years of support, a high stipend level plus tuition and fees also apply in the fall. You can apply as either a senior undergrad, first year or second year student. Not nearly as many fellowships as in the GRFP, but a lot more than 16 a year as in the Hertz one. But here's the rub with these national defense. The research project must be defense related. Last fellowship I'm going to mention is one that you aren't going to be applying to right now unless you are actually already in graduate school and in a lab, and this is from the National Institutes of Health. And these are the so-called F31 awards, the Ruth Kirstein Predoctoral Awards. You must be in a research lab already, and unlike the GRFP fellowship, this fellowship is a collaboration between the student and the research advisor. So the application is reviewed, they review both the research advisor and the student, and the research plan is a definite collaboration between the two. So that's something to think about in the future, but not now if you're not in graduate school, if you're just a first-year graduate student. More like if you're a second-year or third-year graduate student. Okay, so that's the last I'm going to talk about. Good luck with everything. It was nice sort of meeting all of you. I saw a couple names that looked familiar to me from our RU program on the participants. And then if there's any questions, I think Justine will read those to me if there are any.
Yeah, so we have a couple of really good ones here if you don't mind taking a couple minutes.
Yeah.
So you touched on it a bit, but I just want to confirm. Are level 1 applicants scored and compared only to other level 1 applicants, or are they really compared across the entire range, levels 1, 2, and 3?
Okay, it's actually kind of both. So the level 1 applicants, when you are a reviewer, you actually look at all the level 1s in your pile at the same time, but once you establish a score, they're put into the pool with all the other levels. So there's not a defined number of level 1s and level 2s and level 3s that get awards. they're all put into the same pool. It's just that the reviewers are told to keep in mind that these are level 1 applicants. They don't have nearly the experience as the level 2 and the level 3. So keep that in mind, especially with regard to their research plan. But they're put into the same pool.
Excellent. That helps clarify a lot. Thank you. So we have one more question here, and I think we can wrap it up with this.
Okay.
So going back to the research proposal and intellectual merit component, how specific do you recommend applicants be in their proposal? Are you looking more for a big picture project? Are you looking for really specific, do you want methods listed? Do you want some experimental specifics included? Or what is your suggestion here?
Right. So you want to get as specific as possible, but bear in mind it's only 2 pages. And one thing I did not mention is that I would highly recommend that there's a single figure put in to that research plan. So that's going to take up some space, right? And so that figure, a great figure would be something that might be a flow chart kind of figure, or something like we show here on our graduate admissions workshop. So a reviewer can see, well, what the basic plan. And so that's going to take some space, but it really helps the reviewers to understand the research. So you can't get into a lot of detail about the methods, but you do have to mention something about the methods so that a reviewer can evaluate it. And then I also recommend, and it takes some space in the research plan, is that the applicant put in at least a paragraph about their plans for science outreach if they receive a fellowship. And that's a great place to put it. So that also takes away a little bit of space for your research plan. So you can't get too detailed, but it's a hard question to answer, really.
Perfect. So actually, I lied. We do have one more, and this one's coming from one of our very own incoming first years, Frankie, who I know is preparing her own application. So I think she probably has a good one for you. So she'll ask it herself.
Okay.
Hi, Dr. Kunkel. My question is for my research proposal. It's a very basic science question, in terms of broader impact, but it does have a potential biomedical application. Is that something that I should completely avoid mentioning at all and just strictly focus on the basic science aspect of it?
Yeah, I would recommend that in the introducing your research, you could say something about how it might be it may be good in a medical way, but in your actual proposal, the specific aims of your proposal, you should shy away from any kind of medical plan.
Okay.
At all.
Okay. Just want to make sure.
Yeah.
Thank you.
All right. I think with that, we can go ahead and wrap it up. Thank you so much, everybody, for attending. And of course, Professor Kunkel, thank you for putting together this fantastic presentation. And we will see you all next week.
Okay. Bye-bye.